Alright, so let's do a few more examples of writing electron configurations using the Aufbau principle. Okay, and so just to remind ourselves, we have n equals 1 in the first period, 2, 3, 4, okay, on our partial periodic table. We're remembering that we have the S block here, the D block is here, and the P block is here. Okay, let's go ahead and write that a little bit better. Okay, so that's this part, you know, so this square right here. Okay, all right, and one thing that I didn't mention last time is that as we're writing electron configurations, once we reach d electrons, then we have to drop back from the principal shell that we're filling to n-1. Okay, and so we're going to see how that works in just a second. All right, so but just to get warmed up, let's go ahead and write the full electron configuration for aluminum. Okay, so aluminum's right there. Has 13 electrons. All right, so aluminum has 13 electrons. So when we finish writing our configuration, we should be able to account for all of those. Okay, and so just reminding ourselves, so 1s1, 1s2, okay, that one's full. So aluminum 1s2, okay, 2s1, 2s2, that one's now full. Okay, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6, okay, now that one's full. We still haven't reached aluminum yet, so we need to continue, okay. So we go back to the S block, and now we have 3s2, okay, so 1, 2, and then here we are, we reach aluminum, and we have 3p1. Okay, and just a reminder also, here are the valence electrons, and these are the core, and remember we can write this out using the noble gas. So the next previous noble gas to aluminum is neon, so we can write the core electrons that way and then just write our valence electrons. Okay, so that is aluminum. All right. Okay, so now let's do the electron configuration for scandium here. Okay, so now we're going to finally get into these d electrons. All right, so writing out the complete configuration, let's do that. All right, and we see that we have 21 electrons. Okay, and so we're going to write 1s2, because all of this is going to be the same all the way until we reach neon, and of course actually even when we reach argon, although we haven't done one like that so far. Okay, so 1s2, 2s2, 2p6, okay, 3s2, 3p6, okay, because we still have to continue. Okay, the next thing in line is 4s, okay, the next orbital in line, so we're going to write down 4s2, and then when we reach scandium, we have to drop back n-1, and so we're going to write 3d1. Okay, now why is that? Okay, so the first thing, let's just make sure we have all 21 electrons, so 2, 4, plus 6 is 10, plus another 2 is 12, plus another 6 is 18, plus 2 is 20, plus 1 is 21. Okay, so let's go ahead and fill these guys. All right, lowest to highest, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, now remember in one of the previous videos I mentioned that the 4s and the 3d are very, 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 very close in energy. So it turns out that the next 2 electrons to fill are into the 4s. Okay. And look at the next, this is the next highest orbital here, is 3d. Okay. So not 4p. 4p is up here. Much higher in energy. Well, not much, but it's higher in energy. So the next place to fill an electron is 3d. Okay? So that's where we end up with having the d orbitals kind of trailing, shall we say. They're trailing an n by 1. Okay? All right. So why don't you take a second, pause this, and write scandium's electron configuration using the noble gas configuration, the previous noble gas. Okay. All right. So let's check our answer. So scandium, okay. All of this, these are all core electrons. Okay. And if we were to write out the electron configuration for argon, this is what it would be. Okay. So we're going to write down argon, okay, 4s2 and 3d1. Okay, now one more thing that I want to say. You will see these written in either order, either the order they're filled according to the periodic table or in order of lowest to highest quantum number. Either way is fine with me for the purposes of this course.